Let me pull this up here. So in chapter, what chapter we're in? 4, we have looked at theoretical, actual, and percent yield. And this basically, tells you how well your reaction went. The theoretical yield will tell you, theoretically, what's the max amount of product you can make. And then your actual yield tells you what you actually made, and the percent yield tells you how well the reaction went. Now we're going to basically change directions, and we're going to look at like volume and solutions and liters. So before we were looking at grams and like a mass, but now let's look at a volume. So let's define some things first. First of all, solutions. So we're going to look at solutions. There is a homogeneous, solutions by definition is a homogeneous mixture in which one component is mixed in another. Okay, so homogeneous meaning it looks the same throughout, and you're mixing two things together. So let's think about salt water. Okay, you have what's called the solute and the solvent. Okay, the solvent is the one in the greatest amount, and the solute is the smaller amount. So if we're looking at salt water, okay, maybe your throat is sore and you want to gargle some salt water. Water is the solvent because that's what's mainly the solution is made of. Okay, is your solvent. And your solute would be your salt because it's the smaller amount. Basically, whatever you're trying to dissolve, that's your solute. So we're trying to dissolve the salt in the water. Okay? So those are some definitions in solute and solvent. You'll hear solvent used a lot. And solvent is basically what you're using to dissolve something. Like water. Water is sometimes called the universal solvent because it's used quite a bit. Okay, there's a dilute solution and a concentrated solution. A dilute solution means you don't have a whole lot of solute in there. And concentrated means you have a whole lot of solute in there. So if I maximize this a little bit so you can see this picture better. This would be a dilute solution. This is just like with food coloring. But you see, this is water and they put a little bit of red food coloring in there, so it's just kind of a pink color, meaning they don't have a lot in there. But let's put, like half the bottle of food coloring in there. Now this is dark, dark, dark red, and that's very concentrated, meaning there's a lot in there, a lot of solute, or in this case, the solute is food coloring. Okay. A way to express this mathematically is what's called molarity. This is your moles of solute versus volume of solution. So what you're looking at is basically how much of your solute you have in there. So if we're looking at salt water, how much salt did you put in there? And we're going to look in terms of moles per liter. Okay, so basically how many moles of salt did you put per liter of your water? And we're going to calculate that. So let's look at this. And the higher, we'll say, the higher the molarity, the more concentrated you are. Okay? So molarity is basically a number, a numerical value to say how concentrated you are. Okay. If 25.5 grams of KBR, actually let's do a simple one first. This is, well, it's not that it's hard, but let's do one that's really simple. So molarity, let me write this on here. Molarity equals to moles of solute per volume of solvent. Solvent. And this is usually in liters. Okay, so moles per liter. So let's say I have, I don't know, 2 moles of solute. I don't know why I can't write today. Of, let's say of salt, sodium chloride. And let's say I have, I don't know, 10 milliliters of solvent. Okay? What is the molarity, okay, in moles per liter? Okay, so the first thing I need to look at are my units. Are my units fine? So if I'm going to change the color here. Okay, my moles of solute, which is my salt, that's in the correct unit. You know, it says I need to be in moles, so that's good. So molarity, I have 2 moles. Okay, and I want my solvent, and we'll say is water, to be in liters. Okay, well it's in milliliters, so I need to convert that first before I can put it in there. So let's do it up here. So we have 10 milliliters. And remember, there are 1,000 milliliters per 1 liter. So this will be 0.01, I believe. Let's see. 1, 2, 3. Yes, 0.01. 0.01 liters when you divide those out. So now I can put this number down here because it's in the right units now. Okay, so 0.01 liters. Okay, so let's see what our molarity is. I have 2 divided by 0.01, that is 200. 200, and we usually write this as a big M. Well, that's a giant M. But 200 M, meaning molarity. Or, if you want to write it, you could say, come on, pen. I don't know why I all said in my pen. Okay, you could do 200 moles per liter. And that equals to molarity. So you could write it either way. So if you see a big M, that equals to moles per liter, okay? So this tells us in 1 liter of water, there are 200 moles of salt, which is actually quite a bit. Anyway, so let's do some more examples. And don't save. Okay, we have 25.5 grams of KBr, so potassium bromide, is dissolved in enough water to make 1.75 solution. What is the molarity? Okay, so remember, molarity equals to moles per liter. Okay, those are the units and the formula if you want. Okay, so we had 25.5 grams of KBr, and let me see, I don't remember the volume we had here. 1.75 liters of solution. 1.75 liters solution. Okay, so we're check our units first before we do anything. Okay, so liters and liters, correct, okay? Grams and moles, that's not correct, so I need to convert grams to moles. So let me go ahead and do that right here. So remember, to go from a gram to mole, that's always molecular weight. Gram, mole. Okay? And how do I know to put gram down here? Because gram's up there and I need to cancel it out. So we need to figure out the molecular weight of KBr. So we have here potassium and bromine. Potassium weighs 39, let's say, and bromine is about 80. Let me come over here. Potassium is 39. This is 80. Okay, that's 80. So we have 39 plus 80, which is 119. So this is 119 grams equals 1 mole. So I have 119 and 1 mole. So let's divide that out. So I have 25.5 divided by 119. That is 0.21, we'll just say. 0.21 mole. Okay, so now I have moles. Check, and I have the liters. This is not, make sure we know, this is not part of that calculation. Here it is. That is that mathematical calculation. This is not part of it. So now let's put it in our formula. Molarity equals to moles, so we have 0.21 over liters, 1.75. I'll put my units. Mole, liter. So if I do 0.21 divided by 1.75, I get 0.12. And that is 0.12 molarity, or you can write it moles per liter. Sorry. Let's do one more example. Okay, how many liters of a 0.125 molar NaOH solution contains 0.255 moles of NaOH? Okay, so they give us the molarity and the moles. We need to find liters. Okay, so we're trying to find liters, so that's what it says. Liters equals, we don't know. The molarity, let's see, the molarity equals to 0.125. 0.125, and the liter, or the moles, is 0.255. Moles, 0.255. Okay, well, recall molarity is moles over liters. Okay, so we know our molarity, 0.125. Okay, our moles is in moles, so that's good. We don't have to convert anything, so that's 0.255. And we're trying to find liters. So now we're just going to kind of cross multiply. So we're going to bring liters over here so we don't have a fraction. So that'll be 0.125 liters equals to 0.255. Okay, now we need to move this over there because we want liters by itself. So 0.255 over 0.125, and let's divide that out and we'll get our answer. 0.255 divided by 0.125 is 2.04. And that'll be liters. Alright, well, hopefully that's helpful, and just see that you can solve for anything. So you could solve for molarity when you have your moles and liters. You could solve for moles if you have a molarity and liter, or you could solve for liter if you have moles and molarity. So try some practice problems and let me know if you need any help. Thank you.